Problem number 17. Solution for this problem you can find on the reference below this video. Four masses M are arranged at the vertices of a tetrahedron of side length A. What is the gravitational potential energy of this arrangement? Solution. For two masses we have this equation. Potential energy of interaction for two masses equal negative g m square over a. And here for four equidistant masses we have 6 pairs of interaction. So it means that we have potential energy equal just negative 6 g m square over a. That's the result, D. Problems number 18 to 20. Solutions for these problems you can find below this video in the description. The following graph of a potential energy is used for questions 18 through 20. This one graph. Problem 18. Which of the following represents the force corresponding to the given potential? Solution. We know that force equal this expression, negative delta U over delta X. And now let's see what do we have on this graph. From the left to negative 10 we have force equals 0. From negative 10 to 0 that will be negative by negative 10 over positive 10, which is positive 1. So that's 1 Newton. For same reason, this from 0 to 10 that will be negative 1 Newton. And from 10 to 15 that will be 0. So totally we have 0, 1, negative 1, 0. And using this presented graphs, we see that only graph E exactly corresponds to this force distribution, 0, 1, negative 1, 0. So E is correct answer. Problem number 19. Consider the following graphs of position versus time. These 3 graphs. Which one is correct? Solution. Let's investigate all 3 step by step. On the first graph we have position is constant, that's 15 meters. And if we look at this graph, we have on 15 meters force is 0. So it means that if we have an object which is not moving, it will not move at all. And graph 1 is correct. On figure 2 we have position is always negative 5. And in this position we have force equal 1 Newton. So it means that our object must move with some kind of acceleration. But we see that it's not moving at all. So it means that second graph is not correct. And on graph 3 we have motion from 10 meters to 15 meters with a constant speed. If we look at this graph, we have from 10 to 15 meters force is 0. It means that object moving without acceleration, and this graph is correct. So it means that correct answer are first and third graphs, which is D, correct answer. Problem number 20. Consider the following graph of position versus time which represents the motion of a certain particle in the given potential. What is the total energy of the particle? Let's see. Solution. This particle moving between -5 and +5 meters. So it means that in points 5 and -5 it has maximum potential energy and 0 kinetic energy. So it's moving between this and this point. So it means that in point 5 or -5 it has 0 kinetic energy and potential energy equal -5 joules. So that's the answer, -5 joules, which is A.